On your calculator, I want you to graph two equations, one in y1 and one in y2. If we have the sine of x plus 3x, I want you to graph that in y1. And then in y2, I want you to graph the sine of x plus the sine of 3x. And compare those two graphs. See if it's the same. I want you to see, can we use the distributive property when we have the sine of x plus 3x? So when we graph these, you see that they're not the same. You just would have to plot some different points to see why it turned out the way it did. So there are some formulas for the sine and the cosine for the sum and difference, for the sine, the cosine, and the tangent. These formulas you just need to learn. So don't wait till next week to learn them. When you work problems, it's best to kind of write the formula out each time, because every time you write the formula, it helps you remember what it is. For the sine of two angles, u plus v, that is equal to the sine of u cosine v plus cosine u sine v. The sine of u minus v v, yes. And that's what your book uses, is u and v. Is the sine of u cosine v minus the cosine u sine of v. So those aren't too bad. The cosine of u plus v is equal to the cosine of u cosine v minus the sine of u sine of v. And then for the cosine of u minus v, the sign just changes. It's cosine u cosine v plus sine u sine v. It's going to take you, you're just going to have to spend a little bit of time learning these formulas, memorizing these formulas. And then if you know these, when we get to the double angle, that'll make it easier. All right? And then tangent, let me move this up just a little bit. Okay, for the tangent of u plus v, that formula is the tangent of u plus the tangent of v over 1 minus the tangent of u times the tangent of v. And then if we do the difference, it's the tangent of u minus the tangent of v over 1 plus the tangent of u tangent v. These formulas can help us find exact values for angles if we use combinations of angles that we know. And that's the purpose for this, to help us find exact values using angles that we already know. For instance, I know you probably got at least the top ones done. Does everybody have the tangents done? Okay, I'll just move them up a little bit. All right, let's say that I want to find the cosine of pi over 12. And I want an exact value. Well, we don't know pi over 12. But we can come up with a combination of angles that we do know that would give us pi over 12. Now what I'm going to do is on the board, I'm going to write down some of those angles we know and convert them to 12ths. So we saw that pi over 12, we have two options. We can either use, what'd you say, pi over 4 minus pi over 6. Or we could use pi over 3 minus pi over 4. It doesn't matter which one we decide to use. Let's just do the pi over 3 minus pi over 4. So I'm going to use, instead of the cosine of pi over 12, let's do the cosine of pi over 3 minus pi over 4. So we're just going to use that formula for cosine. Now this is what I was talking about. You want to write it out each time. The cosine formula is going to be the cosine of pi over 3 cosine pi over 4. This was minus, so this has to be plus. The sine of pi over 3 sine of pi over 4. All right. We know what the cosine of pi over 3 is. What is it? 1/2. And the cosine of pi over 4? Square root of 2 over 2. Plus the sine of pi over 3? And the sine of pi over 4? You're going to see a lot of these numbers looking the same. So here we get the square root of 2 over 4 plus the square root of 6 over 4. And that is the exact answer. We could write it as the square root of 2 plus the square root of 6 all over 4. And that is an exact answer. If you wanted to, you could check on your calculator by typing in the cosine of pi over 12 and then typing in the square root of 2 plus the square root of 6 and dividing it by 4 and see that you get the same answer. That is not exact, though. This is your exact answer. We're going to do the sine of 19 pi over 12. And again, we need to get some conversions for our angles that we know, those familiar angles, to see what we can get that would get us to 19 pi over 12. So I'm going to go back to the board. All right, so we saw that this is equal to the sine of 5 pi over 6 plus 3 pi over 4. Now, when you're adding, does it make a difference which order I put them in? No. It might make a difference when I subtract. That's mine.
It's coming from the trash.
We still got the lady in the hospital, so that's... Thank you. The sine of 5 pi over 6 cosine 3 pi over 4 plus the cosine of 5 pi over 6 sine of 3 pi over 4. Sine, positive or negative in the second quadrant? And the cosine is negative. Okay. So the sine of 5 pi over 6 is 1/2. And the cosine is? Okay. The cosine of 5 pi over 6 is... Wait, did I do... Oh, I did that wrong. That's right. Let me erase that. Square root of 2 over 2. Thank you for catching that. Okay, the cosine of 5 pi over 6. And the sine of 3 pi over 4. Notice you're going to see these same numbers popping up a lot. So here we get a negative square root of 2 minus a square root of 6 all over 4. And that is an exact answer. You could also write it as the opposite of the square root of 2 plus the square root of 6 all over 4. Those are the same answer. I want to find the exact value of the cosine of 75 degrees.
Whoa.
All right, we're thinking angles we know. Angles we know. This is going to be easier. It should be easier than radian measure. Because what adds up to 75 degrees? Noah, what adds up to 75 degrees? Angles that you know.
30 and 45.
30 and 45. So this is the same as the cosine of 30 degrees plus 45 degrees. Okay, you take a second and you determine what that is. So Corbin, what do we get?
Square root of 6 minus 32 over 4.
Square root of, okay, square root of 6 minus the square root of 2 over 4.
Yes.
Everybody agree? Corbin, you need to finish it and make sure that that's what you get. All right. What if we have a problem like this?
I don't know. Can we multiply them and add to
Okay, wait a minute. Let me get it written out.
Oh, I know.
And I want to write this as either the sine of an angle, the tangent of an angle, or the cosine of an angle. Which formula is that? What formula does that look like?
Cosine,
Sine,
the sine,
sine u plus v.
Okay, it looks like,
Was that just sine degrees at the end?
30, sorry. All right, so you said this looks like the sine of u minus v? What is u?
135.
What is v? So we could simplify this to the sine of 105 degrees. So there you're going backwards. And you may see some questions like that where it asks you to write it as the sine or the cosine or the tangent of a single angle. They're just asking you, even if it lists all three, it's asking you, okay, recognize which formula is this and rewrite it in terms of one angle using that formula. Okay? And you recognized correctly that that was the sine of u minus v. All right, another thing that you're going to be asked to do is find the exact value of the sine of u plus v. So we'll be using the sine of u plus v formula. But we're given that the sine of u is 4/5. And we are between 0 and pi over 2. What is that telling me? Between 0 and pi over 2. Stephen, what does that mean if it tells me that the angle is between 0 and pi over 2?
That you stay in the first quadrant.
Good. First quadrant. We're going to be in quadrant 1. And then I know that the cosine of v is negative 12/13, and we are between pi over 2 and pi. So, Chris, what is that telling me? That if the angle is between pi over 2 and pi? Quadrant 2. All right, so angle U is in quadrant 1. Angle V is in quadrant 2. Now, if I'm going to use this formula, the sine of U plus V, which is the sine of U cosine V plus cosine U sine V, what do I have to find?
The cosine u
I need to know what is the cosine of U
and sine.
and the sine of V. All right. Do you remember how to do that? We're going to have to find the cosine of U and the, sine of V. Sine of V. The cosine of U and the sine of V. Remember that we can use the Pythagorean identities to come up with an unknown side. So we just found out that the cosine of u by using right triangle Pythagorean identities is 3/5, and the sine of v is 5/13. Okay. Then you can just plug in those values here. The sine of u is 4/5. It's not the sine of 4/5. The value is 4/5. 4/5 times negative 12/13 plus the cosine of u is 3/5, and the sine of v is 5/13. And you just multiply that out. Okay, we would get negative 48 plus 15 over 5 times 3 is 15, 65, which is negative 33 over 65. The main thing there is that you remember to find the unknown value by using your Pythagorean identities in a right triangle. Okay. Questions on that one? Do y'all remember what time the bell rings?
It's like 9.
Okay, one more thing I want to show then. No, this is, again, we're just using these formulas over and over again. We want to prove that the cosine of pi over 2 minus x is equal to the sine of x. I want to verify that that's true.
Oh my gosh.
Okay, we're just going to use the identities that we just learned.
Hey, that's...
We know that. We know that's true. Now we're going to prove it analytically. This is a cofunction. This is a cofunction. We're going to prove it analytically now. Now we have the tools. Before we didn't have the tools. And Tim, I'm very proud that you recognized that that was a cofunction. Okay, so if we use our cosine, it's the cosine of pi over 2 cosine x plus the sine of pi over 2 sine x. I simply used the formula for the difference of two angles using the cosine.
Didn't you just prove it knowing that that...
Okay. What is the cosine of pi over 2, Colleen?
Cosine of pi over 2 is 0.
0. So we have 0 times the cosine of x. And what is the sine of pi over 2, Adam? 1. So we just proved that that is a true identity.
Oh, so now we're proving the identities.
Yes, but that was easy to do now that we have those formulas.
Yeah, I
Page 402, 1 through 6. I think those are just fill in the blank.
She said one more thing.
I think, I'm not sure. I think those are 9 to 18 times every third, 30 to 48 every third, and then 63 to 69 every third. So I tried to skip around to give you practice with the different types that we looked at today.